Today we will talk about supply chain planning and control. This chapter discusses two important topics related to supply chain management. The first issue addressed is the planning and control of manufacturing in the supply chain, particularly in relation to managing independent demand items. The focus here is on developing a game plan for the supply chain, which involves strategies and tactics to effectively plan and control manufacturing activities. The chapter also examines the unique characteristics of retail supply chains, which are driven by market demand rather than traditional supply chain considerations. This shift in focus poses specific challenges for supply chain planning and control. The chapter explores the implications of this market-driven approach and discusses how it affects decision-making processes in the supply chain. The second issue explored in the chapter is the problem of poor coordination in retail supply chains. The chapter highlights various initiatives that have been introduced to address this challenge and improve coordination. These initiatives include Efficient Consumer Response (ECR), which aims to enhance the efficiency of the entire supply chain to meet consumer demands effectively. The purpose of a manufacturing planning and control (MPC) system is to enable managers to make the right decisions in order to meet customer requirements. The system coordinates information on key processes involved in sourcing, manufacturing, and delivering products to ensure efficient and effective material flow. Three time horizons are considered in these processes: long-term, medium-term, and short-term. In the long term, capacity provision decisions are made to determine how much capacity is needed, when it is needed, and what type of capacity is required. These decisions are strategic and can span up to 20 years, including planning new model ranges, outlining volumes, and considering internal and supplier capacities. In the medium term, supply and demand are matched in more detail over the next 12 months. This involves planning material provision, capacity, and resource availability, such as manpower. The plan is regularly updated to ensure forecasted demand can be met. In the short term, the focus is on meeting day-to-day demand as it arises. Weekly production plans are created to fulfill specific customer orders. Changes in customer demand, facility issues, or supplier shortages may affect the achievement of the medium-term plan. Short-term plans help managers identify corrective actions needed to address problems and are refreshed on a daily or weekly basis. Okay, now MPC system. The main modules in an MPC system include demand management, collecting demand from various sources, both external, forecasts and orders, and internal, other units within the organization. Independent demand items are managed until the customer order decoupling point, beyond which demand becomes dependent. Forecasting is done at different levels, including sales and operations planning and master production scheduling. Resource planning. Balancing demand and capacity by considering manufacturing capacity in the long term and machine and manpower loading in the short term, ensuring marketing plans align with the available resources. Sales order processing, SOP, matching demand management and resource planning to maintain a balance between demand and supply. Checking manufacturing capabilities for new inquiries and coordinating across multiple manufacturing units if necessary. Master production scheduling, MPS, disaggregating the SOP into detailed plans for individual stock keeping units, SKUs, by major production facilities. handling the planning details and providing feedback on orders and stock replenishment status. Material and capacity planning. Developing detailed plans for each part and sub-assembly based on MPS data. Material requirements planning, MRP, takes the MPS data and breaks it down into component and sub-assembly plans, which are then checked against available capacity using the capacity planning module. The outputs from the material and capacity plans are instructions to suppliers, manufacturing, and distribution, including purchase orders, works orders, and shipping orders. These instructions form the source make-deliver processes. Monitoring achievement against the schedule is crucial, and failures to meet the schedule require remedial actions such as overtime or outsourcing. The MPC system is connected to the Enterprise Requirements Planning (ERP) database, allowing seamless integration with other modules like Human Resource Management, Finance, and Sales and Marketing. SAP, for example, includes MPC systems as part of its supply chain software suite, covering supply chain planning, execution, collaboration, and coordination. This section addresses the complexities of managing material flow in the supply chain, specifically focusing on planning and controlling factory output. The central firm within a network of suppliers and customers is examined, highlighting the connections and differentiating between independent demand, influenced by external factors, and dependent demand, influenced by the firm's actions. The management of inventories for independent demand items using order point methods is explained. The concept of economic batch sizes, EBQs, and order sizes, EOQs, is introduced. EBQ determines the optimal quantity of pots to produce at a time, while EOQ determines the ideal quantity of pots to order from suppliers. Both concepts assume stable demand and aim to replenish stock when it falls below the reorder point. The trade-off between changeover costs and inventory carrying costs is considered when determining batch sizes and order quantities. The formula for EBQ aligns with the just-in-time JIT principle of producing based on actual demand, emphasizing pull scheduling. The EOQ calculation addresses the question of how many pots to order, taking into account the cost of placing an order and inventory carrying cost. Both EBQ and EOQ calculations rely on specific assumptions about demand rate and cost factors, which may need adaptation to shorter history periods and market turbulence. While EBQs can result in varied stock holdings for different part numbers, simplifying the ordering process and embracing JIT principles can align EOQ with the ideal. Although EOQ principles are commonly applied for ordering independent demand items like spare parts and office supplies, they are not directly used in manufacturing end products. Okay. Now to address the limitations of EOQ models, an alternative method known as the periodic order quantity has been developed. In the EOQ system, a fixed order size is placed when the inventory falls below the reorder point, but it struggles to adapt to rapid changes in demand. The periodic order quantity method offers a solution by revising reorder quantities more frequently. It uses the mean time between orders, TBO, calculated by dividing the EOQ by the average demand rate. In a scenario with fluctuating demand, this method generally results in a lower mean inventory level compared to the EOQ system. Illustrating this with a 10-week scenario of variable demand, The periodic order quantity method shows a decrease in average inventory holding from 5,150 to 4,150 units compared to the EOQ system. Despite maintaining the same number of orders, the order quantity varies between 200 and 1,800 units, demonstrating its adaptability to changes in demand. Retail planning and control challenges. Retailing poses distinct planning and control challenges compared to manufacturing, highlighting the following key aspects. Balancing stock levels. Striking a balance between having sufficient stock to generate sales and avoiding excess stock is crucial. Excess stock can lead to losses, making it essential for retailers to manage stock levels efficiently. Wide product range. Retailers often deal with a vast array of products, sometimes numbering in the thousands. Maintaining on-shelf availability for all products is vital to meet customer demands. Coordinating internal supply chain. Retailers must coordinate various stages of the internal supply chain, ensuring products are available on the shelves for customers. Effective coordination is essential for generating sales. Tight profit margins. Profit margins in retail, particularly in grocery retailing, are often narrow. Factors like shrinkage due to theft or process failures can erode these margins, necessitating careful management. Unpredictable demand factors. Demand in retail is influenced by unpredictable factors like seasonality, fashion trends, endorsements, and promotions, adding complexity to demand forecasting. Obsolescence pressures. Fresh produce in retail comes with expiration dates, increasing the risk of obsolescence and impacting inventory turnover. Complex reverse logistics. Reverse logistics in retail involves the return of products from stores to various supply chains, requiring efficient coordination. Retailers prioritize customer choices and market connections over supply chain management. The core competency in retailing lies in trading and profit-making. However, retailers may have limited understanding of manufacturing constraints. An example involving a high-volume ambient product, like washing powder, illustrates how retailers expect suppliers to manage demand uncertainty through buffer stocks. Manufacturers, facing challenges in aligning production with retail orders, employ strategies like projective forecasting and sales-based ordering (SBO) to match supply with point-of-sale (POS) demand. Coordination between retailers and suppliers can face strains due to the pressure on supplier prices driven by the trading function of the retailer. OK. Inter-firm planning and control. This slide highlights the importance of advanced modeling data for effective logistics planning and control within a company. Precision in both planning and execution is crucial, and the complexity of the task escalates with increased product variety, more component parts, and additional levels in the bill of materials (BOM). Coordinating logistics among supply partners becomes even more challenging with a greater number of involved processes. Several factors contribute to the difficulties in logistics coordination. 1. Differences in process technology. Suppliers involved in diverse manufacturing processes face challenges in coordinating intricate tasks, especially during peak sales periods. For instance, a supplier between aluminium sheet producers and canning lines may struggle with tasks like deep drying and printing cans with sophisticated designs. 2. Differences in working routines. Variances in shift patterns, employment conditions, holidays, and shutdowns among supply chain partners can disrupt replenishment coordination. Retailers operating 24/May 7th require specific quantities delivered on particular days to meet weekend sales demand. 3. Priority planning. The prioritization of orders may differ among supply chain partners, leading to misalignment in order processing. An order of top priority for the focal firm may not be recognized as such by upstream partners. 4. Inadequacies in MPC systems design and manufacturing planning and control. MPC systems with design flaws can hinder efficient operations. For example, challenges may arise when shifting from make to stock (MTS) to make to order (MTO) due to long planning intervals and slow planning runs. Weak MPC systems in network partners can create problems for the entire supply chain, emphasizing the need for robust systems and best practices in demand planning and forecasting. Implications of poor coordination. Poor coordination within a supply network can result in the bullwhip effect, characterized by the amplification of changes in demand as it moves upstream in the supply chain. This phenomenon occurs when retailers order large quantities to minimize transport costs, leading to irregular and exaggerated swings in orders for suppliers. The initially stable demand at the retail level becomes distorted and unpredictable, causing increased manufacturing costs for suppliers and necessitating varying levels of stock. The bullwhip effect has wide-ranging implications across the supply chain, causing fluctuations in capacity needs and inventory levels. Contributing factors include the updating of demand forecasts, order batching, price fluctuations due to promotions, and issues like rationing and shortage gaming. These factors amplify demand variation, presenting challenges for effective supply chain management. Furthermore, supply chains can experience chaos, marked by a periodic and bounded behavior with deterministic dynamics. This chaos prevents supply chains from reaching stable equilibrium, and even small changes made to optimize one part of the supply chain can have significant impacts on other components. It is crucial to view the supply chain as a complete system and prioritize communication of demand information upstream to mitigate chaos and enhance overall performance. Now, how can we overcome poor coordination in retail supply chains? To tackle the challenges highlighted in the last section, several initiatives have been introduced to enhance coordination among supply chain processes in the retail sector. The primary goal is to replenish stock in retailers' stores based on point of sale (POS) data. While early efforts focused on manufacturers enforcing this approach, recent initiatives acknowledge the importance of collaboration across logistics processes at each supply chain stage. The implementation of such coordination initiatives can yield numerous advantages. These include reduced inventory levels, quicker response to demand fluctuations, improved on-shelf availability (OSA), and ultimately increased sales. The journey towards improved coordination starts with efficient consumer response (ECR), primarily emphasizing food and fast-moving product categories, and extends to quick response (QR), primarily targeting non-food categories. These initiatives are designed to boost supply chain efficiency, minimize waste, and optimize operations by aligning replenishment activities with actual customer demand. Emphasizing collaboration and data-driven decision-making helps address challenges related to demand forecasting and inventory management in the retail supply chain. Efficient Consumer Response, ECR. ECR is an industry initiative that initially focused on the grocery sector, aiming to integrate and optimize various aspects of the supply chain. This includes product assortment, promotion, new product development, and replenishment. The overarching goal is to meet changing customer demands through effective collaboration among all supply chain members. The ultimate aim is to improve merchandising efforts, inventory flow, and supply chain administration. EC are originated from the work done by Kurt Salmon Associates in the apparel and grocery sectors. It gained traction due to increased competition from new retail formats and joint initiatives between major companies like Walmart and Procter & Gamble. ECR programs commenced in Europe in 1993, with a focus on projects and surveys analyzing the grocery supply chain. The core focus of ECR is on integrating supply chain management with demand management, emphasizing collaboration between suppliers and retailers. While early studies often concentrated on the supply side, there has been a shift towards a more holistic view of the supply chain, encompassing demand and category management. ECR has also spurred collaborative efforts in areas such as electronic data interchange, ED, cross-docking, and continuous replenishment. ECR initiatives encourage collaboration between manufacturers and retailers, necessitating effective logistics strategies and the utilization of administrative and information technology. Customization of existing tools is crucial to maximize their potential. The main areas addressed under ECR initiatives include category management, product replenishment, and enabling technologies, offering opportunities for both individual and integrated improvements to enhance efficiency. Okay, there are 4 initiatives aimed at enhancing supply chain efficiency. 1. Category management. Category management has gained popularity in supply chain initiatives, focusing on preventing stockouts and improving supplier-retailer relations. It aims to balance retailers' product volume and variety objectives. Activities include capturing and utilizing knowledge of consumer attitudes and choices. ECR, by focusing on category management and measuring promotional efficiency, helps reduce supply chain inventory levels, streamline product flows, and use cross-dock options. 2. Continuous replenishment. Continuous replenishment provides opportunities for efficient inventory management. The 6 stages of the product replenishment process integrate the supply chain from product suppliers to end consumers. Effective replenishment strategies require capabilities like joint inventory management, cross-dock operations, continuous replenishment, effective logistics strategies, and quick response. 3. Enabling technologies. ECR relies on enabling technologies like scanning data, data warehousing, and data mining. Examples include ED, which synchronizes trading data among supply chain partners. Effective information sharing, automated order generation, barcoding, and scanning technologies are essential. Data shared includes demand/consumption/sales information, cash flow, stocks of finished goods/work in progress, delivery, and output status. RFID technology is becoming widely used for product tracking, offering advantages over barcodes. 4. RFID technology. Radio frequency identification, RFID, involves attaching tags to merchandise, providing detailed information to readers about the product's nature and location. RFID allows for remote detection, overcoming line-of-sight limitations. Offered benefits include tracking products in the supply chain, intelligent shelves, automation of checkout processes, and enhanced customer information. Challenges include tag prices and privacy concerns. These initiatives aim to enhance supply chain efficiency, reduce waste, and optimize operations through collaboration and data-driven decision-making. Collaborative planning, forecasting, and replenishment (CPFR) is a strategy aimed at enhancing collaboration between buyers and suppliers to improve customer service and inventory management efficiency. Electronic collaboration in supply chain management offers various advantages. 1. Improved product availability. Electronic collaboration enhances coordination and information sharing, leading to better product availability and potentially increased sales. 2. Enhanced total service and cost reduction. By reducing uncertainty and improving coordination, electronic collaboration optimizes processes, resulting in improved total service levels and cost reductions. This includes minimizing waste and optimizing resource allocation. 3. Integration of processes. Collaborative systems simplify, standardize, and speed up processes by integrating them across multiple companies, improving overall efficiency. 4. Quick and structured communication. Electronic collaboration enables quick and structured communication across the supply chain, providing transparent access to up-to-date information for better decision-making and reduced delays. 5. Auditability. Collaborative systems offer an audit trail, allowing users to track when information was amended. This traceability enhances accountability and facilitates error detection and resolution. 6. Email prompts and authorizations. Collaboration systems can send email prompts, update users on variances, and facilitate confirmation of authorizations, ensuring smooth workflow and timely actions. 7. Monitoring and evaluation. Data captured in collaborative systems can be used for monitoring and evaluating performance, enabling better analysis, identification of improvement areas, and informed decision-making. 8. Time and cost efficiency. Electronic collaboration accelerates processes, enabling quicker completion at a lower total cost. Automation and streamlined workflows reduce manual effort and administrative tasks. 9. Increased commitment and visibility. Collaborative systems foster shared plans and objectives among trading partners, leading to increased commitment. Changes and updates are immediately visible to all stakeholders, enhancing transparency and alignment. Companies adopting the collaborative planning, forecasting, and replenishment (CPFR) philosophy, such as Walmart, Sara Lee, and Procter & Gamble, have experienced benefits like improved sales, reduced inventory levels, shorter replenishment cycles, increased supply chain visibility, and enhanced forecast accuracy. Vendor-managed inventory (VMI) is an inventory management approach where the supplier takes charge of managing and replenishing inventory based on the customer's sales and inventory levels. The supplier monitors this information and initiates replenishment orders, aiming to maximize product availability while minimizing inventory costs. Effective teamwork, supported by real-time demand data transmitted through electronic data interchange (ED) or internet-based applications, is crucial for VMI success. Benefits of VMI include enhanced supply chain control, reduced demand amplification, and the potential to shift from traditional push scheduling to pull scheduling based on actual demand. However, challenges in implementing VMI include retailers' reluctance to share data, managing seasonal products, high investment and restructuring costs, increased retailer dependency on suppliers, lack of standard procedures, and the need for system maintenance to ensure accurate inventory records. Quick Response (QR) is an approach developed in the US textile and apparel industry to address competition from overseas manufacturers. It focuses on meeting customer demand by ensuring the right quantity, variety, and quality of products at the right time, place, and price. QR takes a holistic supply chain perspective, mapping the entire process from raw materials to final product delivery, evaluating key performance measures such as lead times and inventory levels. The analysis revealed that excessive inventory was mainly due to a lack of communication among supply network organizations. Unlike a time-based approach, QR uses actual customer demand to drive product flow, relying on information technology, including uniform product codes and electronic data interchange, (ED). Merchandise information collected at the point of sale is sent to suppliers via ED, guiding production orders based on real-time data. Strong links across the supply chain, common barcode standards, and data exchange formats are crucial for QR implementation. While integration can be challenging, internet-based applications are helping to reduce setup costs, making QR more accessible.
Thank you for watching. If you liked this video, please like and subscribe to channel.